Any ordered arrangement R of M objects is called a permutation. MPR means out of M object, permute R. Out of M objects, and those objects must be ordered, you need to permute them in R ways. Introducing permutations, we're going to list all the possible permutation, ordered arrangements of two letters from this collection A, B, C, D, from a collection of 4 letters. Well, we're going to have AB, AC, AD. Then we're going to have BA, BC, BD. Remember, AB and BA are not the same because order matters. CA, CB, CD, and DA, DB, and DC. For B, we're going to determine the total number of permutations of these 2 letters. Out of 4, permute 2, and we just have to add the elements of the list. Altogether, we have 12 permutations. Out of 4, permute 2 is equal to 12. We're going to use for CBCR, basic counting rule, to determine the number of possible permutations of 2 letters. And for the first one, we'll have 4 choices. For the second one, 3 choices. And we need to multiply them together to get the total. And the total is 12. Consider the collection of objects consisting of 5 letters, A, B, C, D, E. We need to determine the possible number of permutation of 3 letters. So we'll make 3 spots for those 3 letters. For the first one, we have 5 choices, 4 for the second, and 3 for the third. Basic counting rules, we need to multiply them together. So it's going to be 5 times 4, 20, times 3, 60. 60 permutations of 3 letters. One observation from the problem solved is that MPR is just M times M minus 1, M minus R plus 1. Here's the formula simplified. MPR is equal to factorial M divided by M minus R factorial. To determine the value of out of 7, choose 3. It's going to be equal to 7 factorial divided by 7 minus 3 factorial. So 7 factorial, 7 minus 3 is 4, divided by 4 factorial. Let's expand 7. 7 times 6 times 5 times 4 factorial divided by 4 factorial. Now, when we cancel 4 factorial, we get 7 for the first, 6 for the second, 5 for the third, multiplied together. This is the basic counting rule. Out of 7, choose 3. Ordered arrangement of 3. Out of 5, permute 2. So it's going to be 5 for the first one, 4 for the second, multiplied together. Basic counting rule, 20. Out of 8, permute 4. 8 for the first, 7 for the second, 6 for the third, and 5 for the fourth. The answer is 1680. Press 7, then math, scroll to probability, then scroll down to NPR, then press 3, enter, and you get your answer, 210. Press 5, press math, scroll to probability, scroll down to NPR, number 2, and then press on 2, press enter, you get your answer, 20. For C, press on 8, scroll to probability, scroll down to NPR, press on 4, press on enter, you get your answer. Out of 9, choose 9. If we're doing it by hand, it's going to be 9 factorial divided by 9 minus 9 factorial. 9 factorial divided by 0 factorial. Remember that 0 factorial by definition is equal to 1. So we ended up with 9 factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the answer, if we want to do it the long way with the calculator, we just enter all the digits, multiply them together, and the answer is 362,880. 362,880. Now, 9 factorial can be done with the calculator just using 9 and then math. You scroll to probability and you go down to 4, which is factorial, and click enter. You get the same answer. 362,880. Out of 6, choose 0. 6 factorial divided by 6 minus 0 factorial. 6 factorial divided by 6 factorial, which is 1. The only way to choose 0 out of 6 is not to choose anything at all. One way. Enter 6, scroll to probability, scroll down to NPR 0, and the answer is 1.